Today's session for openBIM Award for finalists covers two categories. The first will be the category of asset management. Our finalists in this category are Engesis, Minucci, Associati, and Costin. ChorusLife, creation and maintenance of an openBIM digital twin for asset management, presented by Julia Minucci. And secondly, we'll have Turner, SBA, BIM and asset management and safety, presented by Andrea Aiolo, and Emmanuel Cardillo. And the second category of facilities management, we will hear from our finalists, Ericon, Wellington Railway Station Façade Condition Assessment, presented by Matt Hayward and Matt Randall. This session is scheduled to last 1 hour and 30 minutes with a short Q&A for the jury at the end. With that, I would like to hand over to Julia for our first presentation. Just get your slides up.
Okay, so good afternoon, everybody. I'm Julia Minucci from Engesis, an IT services and consulting Italian company. I will be presenting to you today our project, ChorusLife, creation and maintenance of an openBIM digital twin for asset management. We developed this and submitted it with our partners, Minucci, Associati Engineering, and IBM for our client, Costin Group. And as you can see from the title, of course, this project focuses on digital twin. But what I really would like you to remember throughout this whole presentation is that we didn't look at the digital twin only as a virtual representation of the physical asset, but as an asset itself, an asset with its own value. And as a team, we firmly believe that openBIM is a key factor to sustain this value and increase it over time. So where did we start? We started with a live case scenario, which is ChorusLife Bergamo Smart District. It's a really ambitious project, the first smart district of its kind, especially in the north of Italy, for which you can see a huge investment has already been made, and which is said to have a great economic impact on the whole northern region of Italy. Also, the area is composed of 70,000 square meters with a wide range of different areas that you can see, like a residential area, hotels, commercial areas, galleries, parking lots, and two interesting areas that are the arena. It's the first of its kind because it will host not only events and concerts, but also esports courts. And the wellness area, which everybody is waiting for, because it will have a sky jogging path that will start in the wellness area and will go on top of the rooftops of the residential area, so people will be able to run on top of their houses. So you can understand why everybody is ready for that. And end of construction should be by mid-end of 2023, so next year. The idea behind this smart district is to offer building as a service, meaning the users will be able to interact directly with the district by using a wide range of services through apps. So for example, they will be able to book their restaurants, their parking lots, they will be able to monitor energy consumptions in their houses and interact with other users through chats and other services, okay? So now, where do we come into this? There is a whole organization getting ready at the moment to provide this service, relying on an IT digital infrastructure, a platform really, that will integrate a wide range of softwares and services, such as facility management softwares, building management systems, and all these softwares will have the same base knowledge derived from the digital twin, which is integrated in the platform itself. Okay, so what happened is that the group Costin, which is in charge of construction and maintenance of this whole district, engaged us, meaning Minucci, Associati, Engesis, and IBM, to define and test an approach that could be sustainable and replicable over time to create and maintain a digital twin based on IFC. Why IFC? It's an open standard, of course, and since, as you have seen, the BIM model will be integrated in a wider ecosystem, so the digital twin will not only be the BIM model, but the ecosystem itself. We needed, of course, an open standard to allow for this integration. As you know, proprietary formats will not have allowed this, and also it would have meant a higher cost of initial investment. Also, the smart district will have to be maintained over time. We're looking at a minimum, and I'm saying minimum of 5 to 10 years, just for getting feedback for the infrastructure and maintaining it. So open standards will also help with that. for updating the digital twin together with the maintenance of the smart district or whatever else will happen in a 10 years time. Also, this approach needed to be replicable, as I said, meaning we needed, and also our client needed to be able to use this approach in different contexts, meaning that you can change whichever of the softwares that are involved in the ecosystem, provided that they are IC compatible, of course, and open and interoperable. Okay, so this approach will be sustainable over time only if we use openBIM. Now, let's look at the approach that we developed. We have developed it thinking about the whole district, and then we tested it on a smaller proof of concept, going backwards. You can see we have summarized the approach in 5 steps using key questions. The first question is which assets to represent, because we needed to understand which assets to represent in the digital twin that were involved in a lot of different processes. Which information containers for those assets, meaning which information do we need to maintain these assets over time, and can we group this information in sets that will be managed by different softwares. And then, of course, which information is contained in each information set. And fourth step is how will the systems in this infrastructure, so the softwares in this ecosystem, manage the information. And this is a key step of the whole process, okay, because the softwares are integrated together and information management is the key part of this. And last but not least, how is the digital twin organized? Now, I will look through I will go through these steps one by one together with you, just to give you an idea. First question, which assets we needed to represent? Now, to answer this question, we had to go one step backwards and do a thorough analysis of the client's needs, meaning we needed to analyze what was the smart district for, which are the key users, so the key actors, and what actions the manager of this district wanted to be able to do over time. So we defined, as you can see, 39 scenarios, half of which are from the point of view of the manager of the district. For example, managing the influx of people, managing maintenance, managing requests from users, okay? The other half from the point of view of the user itself. So I want, for example, as a user to be able to book a parking slot near my house. I want to manage the illumination consumption or the light consumption, the energy in my house, etc. We needed to establish if for these scenarios, we needed to be able to visualize some key actions in a BIM model. And then we went more granularly into the analysis to identify some use cases. We identified 40 use cases, and then we created a matrix because we wanted to see if these use cases would be useful to implement more than one scenario. And with that matrix, we were able to identify key use cases, priority use cases, let's say, to look at first. So with that, we established also if the use cases could be linked to a BIM model or not. And from there, we were able to finally identify the asset list, meaning we identified 246 asset types, as you can see. For each of these types, we defined an IC mapping, shape representation, and key information requirements. Of course, we also needed to understand if these assets needed to be included in the IC model, so to be represented in the IC model. And as you can see, 90% of them were indeed included. Now, I said that for each asset, we identified information requirements, but if you look at the approach, the second question was which information containers? Why? Because to understand the information that is associated to the assets, we needed to understand how the ecosystem could work. As I said before, different softwares that have the same base knowledge. So this means that they will manage same or common sets of information. We identified 17 information containers. To give you an example, the first one is shape and geometry, or we also have static properties associated to assets, or asset-related documentation, dynamic project properties, and within each of these containers, of course, there are properties, asset-related properties. Okay. Then you see in this matrix, you don't really have to look at all the columns, but I will explain it briefly. What we did was, after we identified the containers, we needed to understand how this information was shared among the different softwares. And especially, we needed to identify which events would trigger either the creation, the modification, or the elimination of the container itself and the information that it contained. So from there, we said, okay, this is the trigger event. Where is this trigger event originated? So which software in the whole ecosystem is the master source of the information? And this was key for the whole project, for the whole approach, because once we established which software was the master source of information, we could say, okay, the other softwares are a slave of this information, so they can also give feedback to the master software whenever they encounter an error that the master did not register. Okay, so after this, we went more into detail into the single properties associated to assets. Since we have mapped the assets types to IC elements, we defined properties specifically for the IC elements. We defined general data, so information that helps to uniquely identify the elements. Static data, properties and information that are relevant for asset management purposes, of course, but that does not change during the life cycle of the asset. So it's static information, probably set during the design phase. And then we have dynamic data. You can see here dynamic data from usage and from design phase, because we're talking about information that will change over the life cycle of the assets due to, I don't know, other trigger events such as maintenance, for example, extraordinary maintenance. But we had to distinguish the information that needed to be set in the design phase, because it probably goes in the BIM model, and information that would come from other systems during the life cycle, so from usage, okay? Now, after this, we needed to understand how the flow of data could work, how this whole package of information could be managed by the systems. So we have defined also for a proof of concept a small, let's say, software map. You can see that at the core of the map there is a digital twin, and we did use Azure Digital Twins for our proof of concept to develop our digital twin data model. We used also a varied type of software such as ArchiCAD for the design phase, openBIM as a facility management software, but the kind of software that we use is not really relevant because they can be exchanged for any other softwares, as I said. But you can see that IFC here was a key factor for having a consistent flow of data that could go from and to the digital twin, okay? Why did we use Azure Digital Twins? First of all, because it allowed us to create a data model however we wanted. In particular, we decided to keep more than half of the information from the IC model, especially we're talking about spatial structure, functional structure, representation of physical elements. And as you can see, 50% of the nodes, so of the nodes of the graph of the digital twin are coming from the IFC schema of the model, of course. And then we also kept the rec ontology that Azure Digital Twin provides. And it was mainly used for main capabilities, barrier assets, and to express the functional relationship between the assets. And of course, we had to extend the graph a bit because we needed integrations with other software, such as the facility management one. Again, why IFC? It's directly related to what I said before, actually. The smart districts needs to be maintained over time, meaning a lot of things can happen, meaning the digital twin needs to be updated. Through the direct integration with the IFC model and the digital twin, we have ensured that this update is possible, and there will be no semantic transformation because we are using an open standard which is widely used and it's interoperable. Now, going forward, I have explained how the approach works. And as I said, we have tested it on a smaller portion of the district, of course. We have selected one of the 74 apartments that constitute the residential area. We have modeled this apartment in our BIM modeling tool. We have exported this BIM model in IFC to be able to populate both the digital twin in the Azure digital twin, and also to start populating the data set in the facility management software, openBIM. And then, of course, in the BIM model, all the information was associated to the elements, so that was exported together in the IC model. You can see here a small view of the integration, but I will show you later in a short video how this came to life. So this is just some more numbers and information about the proof of concept, so the small test that we made. What is key here is that out of the 39 scenarios and the 40 use cases, we selected 2 scenarios, and we are talking about the point of view of the manager of the smart district, in particular the management team, so maintainers and the maintenance manager. And we looked at 4 use cases, which are mainly describing the activities of an operator that needs to work on a maintenance ticket that was opened by a user of the district. Okay, mainly in the apartment, of course, because this is what the proof of concept is about. The 4 systems involved were, of course, the one that you saw in the ecosystem map from before. So openBIM for the facility maintenance, Azure Digital Twin, and then ArchiCAD for the BIM modeling tool, and Mix as the visualization of the model. Now I will show you a brief video which shows part of the proof of concept, just to give you an idea of how it came to life, how it already started. Okay, so the operator in the room receives an alarm about an anomaly. When he goes to check, he discovers the anomaly is about temperature in the apartment that is beyond comfort limits that were set. So he can do a digital inspection of the model of the apartment and check if this information is true or not. So the detected temperature and humidity, which is out of comfort zone. He can check in the model if the window is open, because that might be the reason for temperature to be too high, and the window is indeed open. So we can see the information directly in the model. And this is possible because behind the scene, there is an integration with the Azure Digital Twin, from which the information was retrieved. So we can manually also look at the window, interrogate it, see some information, and look at its status, and simulate, in this case we do it manually, the window status closed. We want to do this simulation because if the status, which is now closed, shown in the model, if the window is closed, then that's not the reason. So the operator can check the air system. In particular, he's checking the air system machine to see if it's working, and it is not. So the value for working is false. He can check through the visualizer if there are any maintenance tickets. There aren't, so he can open it directly there. And when the ticket is open with all the information required, this information is saved directly in the facility management software. So the facility management software is, of course, integrated in the digital twin environment, as we said before. And here we see how the manager receives the ticket in his dashboard and can assign the maintenance task to the right team. He can do it, of course, from his dashboard, and then the operator can see the assigned ticket in the model. He can go and check information of the assigned task, and he can also actually work on the task directly from the model because it's integrated. Now, this was really a brief video to show how this whole integration will work and how it will, of course, improve the management of the district itself. Of course, there are some. How do I go forward? Sorry, is it starting again? Okay. Yes. Of course, there are some key, let's say, key results here that we want to bring home. In particular, we think that openBIM, this project was a driver for innovation. especially because we believe that we have shown that IUC is not only file format, it's an open standard, yes, but it's also a data model, and it can be used to integrate different tools, also tools that are not thought at the beginning for BIM-oriented purposes, such as, for example, the Azure Digital Twin. And also, we have shown how is it possible to define an approach that will be useful in the long run for everybody in any context. Okay, because you can, as I said before, change some softwares and the approach will still work. Now, this proof of concept will be in the future, in the long term, replicated to the whole smart district. That is the plan, of course, of our client. And it should, the plan also, let's say, include some other buildingSMART standards in the future, such as, for example, the BSDD, to include external classifications. But that is the long-term plan, let's say. So for the moment, short-term plan is to extend this proof of concept to the smart district. Now, to conclude, and I'm done, this is the team. So as I said before, we have worked together with our partners, Façade Engineering and IBM. I'm from Engisys, as I said before. And this was the core team that developed this, together with our client, Costim, without whom, of course, this whole project would not have been possible. So I will thank all the team for this, and also all of you for listening to my presentation. If you have any questions or doubts, I will be available at the end of this session with the rest of the presenters. Woo! Thank you.
Thank you, Julia. So I'll invite you.
Okay. Good evening to all. I'm Emanuele Cardile, and now with my colleague Stefano Ricci, we'll talk about our experience as a transmission system operator, Terna, with ACA software. In particular, the aim of the following presentation is to explain how the new way of design and manage the asset is led by improving our digital approach during its entire life cycle. We start from the design phase, and then we have carried out a specific use case. Next slide, please. Well, we started the following slides, starting with the presentation of Terna and the reason why we decided to join the contest, explaining the activities carried out during the last months with ACA software, including the use case proposed. We will explain our experience underlining the benefits achieved, leaving some minutes at the end for question and answer. Next slide. So, in this slide, we have some numbers that represent Terna. In particular, we are the largest independent transmission system operator in Europe. So we manage the Italian transmission grid for high voltage, and we are enabling the transformation of the electrical power system towards renewable sources, ensuring a safe and efficient operation. Just a few numbers that characterize the Italian transmission electrical system. It's composed by 897 high voltage electrical substations that interconnect almost 75,000 kilometers of high voltage power lines and manage 26 interconnections with foreign countries. The first implementation of BIM solution in the Italian TSO industry have been done by Terna with ACA software as a partner chosen thanks to its leadership for implementing engineering products. Okay, next slide. So, before starting with the technical presentation of the software developed, it's important to give some information. Terna has always based its technical approach on the unificazione that consists in a standardization of substation architectures called Progetto Unificato, Unified Project. It's composed by an organic collection of technical documents and a specification supporting the colleagues in the standard design of an high voltage substation. In this context, Terna has taken the opportunity to upgrade its unification content, adapting it to a new openBIM workflow, enabling an organic information management. It is a use of BIM methodology in a context quite different from the classic ISC world. Adopting a digital approach since the design stage, with the aim to extend it to the asset management activities throughout the life cycle of the asset. Okay, next slide. So, BIM implementation in Italy started from our legislation, national laws and technical standards submitted between 2016 and 2021. Those standards have established the rules and criteria for the application of the new methodology. We decided to model each element feeding out the technical object library, composed by 1,500 objects available for the two stazioni. It allows a quick design of a new high voltage substation with the appropriate level of detail. The BIM project is efficiently managed thanks to the common data environment that allows to extract information directly from the BIM model. Okay, next slide. So there are essentially three categories of BIM objects, consisting in civil, geotechnical, steel structures, electrical equipment, and electrical machines. Each object has been modeled following Terna requests, needs, and design standards. The information container associated to each object derived from the shared technical datasheet. Moreover, the construction details are available from the object as attachments. Leave to Stefano for next slide and video.
Okay, let's play the video. Okay. This video is represented the software user interface. Exploring the object library, we can easily consult all the standard elements modeled. In this case, for instance, we are exploring electrical equipment and machines with the related geometry and properties based on Terna standard project. Sorry. As you can see in the video, we can add or modify the properties of a generic project or a generic object uploaded in the library or used in a generic project. It's important to note that we have two different kinds of attributes. In fact, there are type parameters that are not editable, and specific project parameters, those are editable. In the specific case of a hybrid switchgear that you see in the video, we have available all the properties of the various components included in the switchgear, that are switches, circuit breakers, current and voltage transformer, and surge arresters.
Okay. Perfect. Let's see next slide. Okay. Moreover, the objects have been assembled to model the typical section of progetto unificato interno, unified project, let's call it, taking into account different voltage levels, seismicity, and short circuit current in order to model quickly a new electrical substation. The level of detail ensured is appropriate for the project phase, even in case of a new substation has to be modeled. You can see next video with Stefano.
Okay. Here in this video, okay. We share the process to model a substation. Here there are various assembled models of typical sections and standard bus bars for different size of substations. In this case, we have pre-assembled sections. So starting from the DWG file or PDF of an existing substation, we can choose the dimensions of the service area, and then we import the pre-assembled models of the substation in order to compose the whole substation in few steps, managing the design through template or custom solutions for specific design needs. Those selected objects have been grouped, shown only to make easier their placement on the area. Otherwise, we can select them one by one to design new configurations. After the modeling process, we can easily extract drawings and design documents from the station 3D model. And this is a brief presentation on how we can explore the project easily through the web browser common data environment. We can organize and manage the digital twin to allow an easy access to details and design documents, thanks to the implementation of indexing and metadata.
Okay, Andrea, can you start with the next slide?
Okay, thank you very much. What we have done in ACCA, basically we have provided the common data environment to develop this project with three main features. Work on the last update data with the cloud-based system that will be available to any device, reducing the time and effort required to cross-check the current status of the project, and establish a point of contact for all the specialists that helps prevent any project inconsistency. The use case I'm going to show you now is just one of the many use cases that we can do now that we have this solution already and running on the clients. This use case is about asset management operation and was made on two power station in close to Bari, for Palo del Colle and Bari Ovest, with 5 steps. The first step is enable collaboration between different business units in order to cooperate in the designing and sharing information. It's used the diffuse in order to create a digital BIM of an existing electric station. Step 3, business users can freely access BIM in situ thanks to a dedicated tablet. Step 4, the access of digital twin file and the report updates is enabled by scanning the QR code associated to a station physical object. And last step, digital twin will enable prediction on maintenance or any future issue. So now a short video is going to show you what we have done just as the use cases. So these two stations are close to Bari. This is what we have done with our tablet. This is the geometrical visualization of the openBIM. You can see in 2D and 3D as I've seen before. I'm sorry for these images, but it was a very sunny day when we recorded this video. So here you can see that we can access the 3D model, the digital twin, and we can navigate directly on the tablet and query all the information we need. By using the QR code scanner, we can select a specific object. So we are going to open the model and just visualize this object on the digital twin. Like here, just scanning the QR code, and then the model is opened, the object is selected, and we can see all the documentation associated with a specific object, everything on the same environment, on the CD. So this is a PDF about this object. Now they are going to move, and for example, they can find a problem, an issue on some object, and we directly from the field we can open a ticket very easily. We scan the QR code again, and we can report a failure, just writing a message to the management system, and this way. We can create a virtual room directly on the CDE to chat with the operator in the office and exchange information, like we can write, we can send a message. We can also open a video call. We can navigate the model together. So we can show him which object is failing now, so to be safe and to be sure that everything is okay. Again, you can, after you have selected, this is the web call, so you can call, you can see each other, also you can speak. So you can work with the people in the office in a very good way. Also, if there is an intervention manually, the operator has to do something in the field, the operator can directly access to all documentation to carry out specific manuals with a guideline like this one. So you can read the guideline provided by Terna and understand what to do in the specific case. This is just a use case based on user management and facility management. So in the field, you have all the documentation in one place to work with it. This is a short audio.
My opinion, it would be very important.
An experience from the field. So.
I was able to get my hands on this project about an hour ago, and the potential is very clear. In my opinion, it would be very important to involve the operational and technical staff of our various offices in order to reach the right compromise of reliability and functionality of the entire system. In fact, we'll certainly be the ones to deal with the use of the system because we know the dynamics and activities at a more operative stage, and therefore we can better support product optimization. What we have done today is an example application, and from this starting point, we can certainly help out in bringing this project further ahead.
I hope you hear the voice, the last. Anyway, this was one use case that we can do now that we have this system running on the client side. What are the main benefits of what we have done with the Terna of this project? Surely time savings, as the process of design station is much faster than before. Error reduction, because they reduce the number of files that describe the same project. Optimization and standardization, as we have everything standardized, so we cannot commit any errors. We can integrate with other software because we use open file, open format file. We have reduced loss of information because the information are all in the same place and they are changed during all the life of the asset. Also, the information are saved on site, so when we open the ticket on site, the error are reduced. And also, all this platform can enable new technology to be applied, like QR code, virtual reality, augmented reality, and many other technologies. Thank you very much. Thank you very much. Manuele, also for difficult to speak from Rome, but thank you, Manuele.
Okay.
Okay.
Thank you so much. So now that's all the finalists in that category. So if we can have all the finalists up in the front, and Emmanuel, if you would be happy to stay on, we'll have questions from the jury now, and then we'll move on to the last presentation in the second category. So we're coming. Yeah. So come on up. Yeah. Did you want your colleagues in your comments as well?
Yes.
Perfect. So, any questions from the jury?
Yeah, of course. Is it a project, the way you work, is reusable for other projects? How?
You mean ours?
Yes.
Okay. Yes. So.
Sorry. Did you not line hear the question?
It's an online here.
Yes.
You heard the question? Did you guys online hear the question?
I mean, I assume no, because they I'll bring the microphone down a bit.
Hi, do you hear me?
Yes, we
Yes.
can.
Good afternoon, everybody. No, we couldn't hear the question.
I will say it again for you.
Thank you.
The question is the project of Minucci. Is that a project that can be done similar also for future projects, for other projects?
Go ahead.
Okay. Yes. So the answer to this question is yes. What we had in mind right at the beginning, and it was a requirement from the client itself, was that this is the first smart district that they are constructing, but they have an idea and a plan to do more in the future. And the softwares that we used, we selected them just because we knew them. But it's not probably going to be the softwares that they are going to use for future projects. So the whole concept was to define an approach, the method, which are those 5 steps that you saw, on how to start from the analysis to the implementation based on the creation of this digital twin using open standards that would enable them to replicate it in the future. So for example, as long as you use the BIM authoring tool that it's open, IFC compatible, you can choose whichever, Revit, ArchiCAD, Bentley, etc. We used openBIM for the facility maintenance just because we already used it in other contexts, so we knew it, and it was less time consuming for us, of course, but same thing can apply for other softwares, such as, I don't know,
Can you also use it for hospitals?
In that sense, yes. I mean, yes. This smart district, as you saw, has a wide range of areas, but it can be used also for a single building or for a complex of building. Yes, of course. The approach is the same. Yes. Sorry,
Any other questions from the jury?
Yeah, I've got one question to the second project.
Yeah.
In the title, project title, okay, great.
Your project title contains the word safety. It's called asset management and safety, but you haven't spoken very much about the safety aspect. Can you elaborate on that, please?
Yeah, maybe Manuele can answer better than me, but just with introduction. For example, Emanuele, vuoi rispondere tu? Hai capito? Ha sentito la domanda?
Guarda il micro. I don't hear because the microphone was interrupted. Can you repeat?
Te lo dico in italiano. Su safety, sulla sicurezza. Nel titolo si parla anche di sicurezza. Che cosa abbiamo fatto per la sicurezza? Quale caso d'uso stiamo implementando?
So at the moment, per la sicurezza, Allora, sì, on distance. Okay.
Okay, for safety, we are thinking to improve the software, checking in an automated way the isolation distance between the colleague, the employer of Terna during the maintenance operation in the substation, in case the substation is under voltage. So there will be an upgrade with which we can test continuously if the isolation distance are respected, the clearances.
This type of check is possible by this model developed with BIM with ACA software, model of an electrical substation. So this is an example, but in the theme of safety, there will be in the future other developing on this theme.
Basically, what we are going to do very soon is connecting the model with the real device on the field. So we can see the element under voltages. So we can see, like said before, Emanuele, the space where you cannot walk when the device are under voltages with using the augmented reality. So now the next step is to connect to the model with the real sensor, and then so we can do a lot of tests for safety like this.
Any further questions from the jury?
Yes, one more about scenarios. You choose two scenarios, you said. You had 39 scenarios.
Right.
What would be the dream scenario?
The dream scenario.
Of those 39, based on your, you have to do something for buildingSMART and openBIM, and this would be the scenario. Which of those?
I think I'll let Senya answer that question.
Yeah, well, hi. You hear me, right?
Yes.
We are talking about the dream scenario. Actually, well, first of all, out of the 39, we had priorities. I would say that the most probably ambitious one was the one for which we had parking space, right? And it was to provide a service for an automated parking slot reservation, depending on the time you are going to the gym in the ChorusLife campus. I would say this one was really, the the most far away probably from the let's say the most pushed in time for realization. Again, out of the 39 scenarios, we had some that were very much related to the users of the campus itself and the inhabitants, and some that were related to the management service team. The one that I've just mentioned about mentioning the parking slots, reserving them, means actually having behind the scenes all the information related to the geometry of the parking, how close it is to the gym, understanding the availability real time, understanding the behavior of the user. So when you are starting to put together the geometry, the behavior of the user, the real time data, that's when the dream scenario comes through. And that's what ChorusLife intends to develop during time, of course. Have I replied to the question?
Yes.
Any further questions from the jury? Good. Thank you very much to all our presenters.
Go for it, eh? Kia ora koutou, ko tainui toku waka ko Ngāti Manipoto toku iwi, ko te kaiwhakahaere matahiko whenua me te wai Aotearoa ki Oricon, ko Matt Hayward toku ingoa. Hi everyone, my name's Matt Hayward. I'm the digital lead for the Land and Water Service Group in New Zealand for Oricon, and my role on this project was I was the client lead for this project.
Kia ora, my name is Matt Randall. I was the developer and main content producer for this project.
So just a bit of a quick run through how this dual presentation will work is I'll be doing the introduction and the conclusion for the project, and then Matt will look after the technical details through the project. So this project is a facade condition assessment on a railway station in Wellington, New Zealand, and looking to use IFC for the automation and the workflows. So the Wellington railway station, it's an old 1930s neoclassical building. It's constructed of steel, concrete, brick facades, and it's got a whole lot of terracotta tile panels which were sourced internationally when it was built. And so we had were engaged to help out with the heritage architect to perform a condition assessment for these panels, which were in varying condition and had a different risk of potentially failing. And so what the challenge was for us was to, first of all, how could we capture these panels, which were quite often up at a really high level. And so we wanted to remove the health and safety element or risk. And also we were in the middle of looming lockdowns, and so how we could come up with a remote and collaborative process for this work to be able to do a condition assessment. So who are we? Who are the clients? So the client's Kiwi Rail. So Kiwi Rail, they own and operate New Zealand's rail networks nationwide. They also provide infrastructure and engineering services for maintenance and improvements for the facilities and assets that help support the rail networks. And who are we? Oricon, we're an international design, engineering and advisory company. I guess traditionally we've been more on the horizontal infrastructure, but we also do vertical infrastructure, and now we're starting to get more into facilities management and leveraging some of our experience in other areas and to find solutions for our clients' problems. So why facilities management projects? I guess we're looking at a bit of a diversification from our traditional services and looking to scale up some of our other industry areas that we've worked in, particularly in the energy and industrial area, and trying to see if we can use some of those systems into other areas. There's a big strategic focus on decarbonisation and material use quantification for the duration of different facilities' life span. And asset life extension, we're finding more and more facilities, assets are at the end of life. So how do we assess and how do we recommend extension? And so what we were trying to accomplish was, I guess, repeatability of a process and then comparison of conditions through time. So why openBIM for this and for future projects? What we're finding is more and more of our clients are now focused on structured data capture and management. They're becoming more and more mature in their asset information requirements and their exchange requirements, and we're starting to see this in procurement documents. Projects also that we need to get better focus on graphical and extensive data for future reuse, so we can reuse the data and over again. There's a massive desire to have an increased collaboration, validation and visibility throughout the projects. And what we're finding is we want to move more away from a locked-in data set and tools or software stack and move more towards open formats and workflows. So what you can see on screen here, this is just a bit of a snapshot of the client or Kiwi Rail's digital engineering framework. So they're quite mature within the New Zealand market and well on their way on their digital journey, and have set up some very good documents for the industry to use. And what we found is in one of the particular documents they've come up with, and they are setting IFC as a format to be submitted for handover. And so we were able to use this in their documents to work to. So what were some of the goals that we wanted to achieve for this project in such a short time frame? We wanted to come up with that remote solution and assessment to help the project team to be able to remove some health and safety risks and also some costs. We wanted to enable quantity takeoff via some code and create the heat maps to help with some trend identification. We were hoping to, I guess, align with the client's digital aspirations, even though they were early on their journey, and help out with that. And then also figure out, could we actually help the supply chain evolve a bit with facility condition assessments? We wanted to see if we could demonstrate the value of risk taking through experimentation through this process, and whether or not we could hand over and integrate into a client system. And then one of the ones for us was that we wanted to demonstrate that IFC can be used collaboratively to author content.
So how do we go about delivering on our goals? So we divided into these strategies and enablers. The main strategies we had were to enable a web digital collaboration environment. In Oricon, we have a concept called Model First, which is a global initiative, but it basically means that the model is in the middle of the deliverables and takes precedence of all the other derived deliverables. Early on, we had to define and agree on the condition types of the tiles and the severity levels. We had to define a grid reference system, tagging and naming, which I'll talk about in a bit more detail as we go. Because it was an iterative process and collaborative process, we had to develop some training and reference material, particularly for the heritage architect to reference. The specific use of IFC is an enabler because it already has a logical tagging system behind it. It has strong and established data structures, levels, spaces, right down to elements and types and materials. The ability to automate using IFC was a key factor because we really wanted to try and improve what we were delivering and really test this handover of IFC to the client at the end. And being able to automate with Python, in particular with BlenderBIM and IFC OpenShell was key. And of course, connecting directly into a visualization system as well, using Blender. Our Exchange ecosystem looked like this. It is divided sort of in thirds, with 2/3 being open source on the right-hand side there. We used BIM 360 for our data capture, Microsoft Office just for CSV management, data tables, Lake Cyclone for point cloud capture, a bit of open source mesh production software to use as the heat map underlays, and this aggregation in the middle between BlenderBIM, Python, and Blender itself that you can see there, and XBIM Explorer just to validate the IFCs were being written properly with the right data in the right places. We developed an informal process chart which played out like this, divided into 4 key sections: investigation, capture and configure, develop and test, and produce. So you'll see that in the top right corner of the slides as we move through, just to see where you are in the process. In the middle there, this is the iterative or experimental stage where we're working with the heritage architect and client just to make sure that our issue entries and heat mapping and push bins were being placed in the right place. All the way down through the bulk condition capture and accumulating schedules and producing heat maps, which I'll show in more detail. Grid reference system. So we divided the capture into 2 stages, which I've hinted at earlier. We didn't really know how it would play out and what would be appropriate. So we went to site and captured with a LiDAR, a point cloud, but also focused quite heavily on high-res photography. Now, the grid reference system was really good in enabling us to divide according to the IFC hierarchy to enable automation. So yeah, building the facades, building stories, bays, panels, elements, and materials. This is what the condition capture looked like. So high resolution images with push pins with drop down lists for condition types and severity levels. We had to do quite a bit of configuration on this, and I'll talk about an iterative version of this in a minute, but the idea was to be able to capture, based on the tag, where that push pin was going to end up writing data into the model, as well as being able to capture adjacent damaged tiles. The way that we generated panels in the information model was to enable a lot of automation and like a programmatic generation. So we traced out the tile and panel profile that you can see on the left there from the point cloud, but also produced these type tile assets, which were pre-loaded with the latter half of the tag, which we were then able to connect to a CSV file, which would not only overwrite the initial location tag information on the left-hand side there, but provide an XYZ location of the panel, as well as its rotation, how many rows and columns there were, but also being able to scale it for the particular position on the building as well. This is what the output was, which was 5,500 tiles arranged in 168 panels on each of the 6 facades. This is the iteration that we had to do in the middle, which would effectively define the capture of adjacent tiles, or make it a little bit more accurate in terms of enabling aggregation or quantification later on. There was the linear, diagonal, and area patterns that we were able to build in, just to make sure that we were on point with the numbers of adjacent tiles. The output from BIM 360 enabled us to then write the data onto the information model and create the heat map, which I'll show in a second. But you can see the number of issues here is about 2,500, all complete with data related to the condition type, the severity level, the asset type itself, and the number of adjacent tiles that were in different conditions. This is what the loading of the data looks like. So you can see pockets of condition there with severity levels from 1 to 4, or green to red. So red being the worst severity level. There, yeah, you can also see the clusters, or the ability to affect the heat map in terms of the replication in areas or lines as well. From that, we were able to aggregate the condition into different facade sheets, which enabled us to effectively present the condition right next to the heat map render itself, just to cut down on the amount of misinterpretation. Because you imagine the amount of tiles in their thousands, there's a lot of opportunity to miss classify or incorrectly label a tile with the wrong severity or damage type. Yeah, and connected directly into Blender, that meant we could repeatedly produce the renders into our report just by means of a bit of Python scripting and updating, reloading through the process that I showed you earlier. This is an example of the heat map just on the southern facade on the western end, severity level, and then this view to being able to detect trends through the actual damage or condition itself, as indicated by the legend on the top right. We definitely favoured the severity heat maps in the end, because those were the key documents that were found to generate the most value for the heritage architect in their assessment.
Thanks, Matt, for that technical information. So, did we achieve what we set out to do? within the goals. So we certainly ticked off a few of the goals. We certainly came up with a remote solution and assessment, which provided the ability to capture everything and have the less need to be on site for both for the project team, and also the ability to create that collaborative way of assessing the tiles via BIM 360. We've used heat maps, created and generated heat maps via code to show what the trend identification and what the severity was like. And we were able to demonstrate the value of risk taking through experimentation. That was also ticked off. Plus, we also believe that we demonstrated that IFC can be used to work together and author something that's more than just a transfer container. There's a couple of yes/no goals, I think, for us around the client digital aspiration and around the facility condition assessment, supply chain evolution. We think they're probably limited just to the project team or the participants for this out of this, and so there's definitely the ability where we need to be able to pass that knowledge on to more throughout the client, ourselves, and into the industry. And then I suppose one that we don't think we met with this one, and potentially it was due to the fact that we're quite early in the journey with the client, was around handover and integration into the client system. That's changed quite a lot since we initially did this work, so we think we'll be able to get that back into the client system, and now that they've developed some of their asset information requirements. So the benefits around IFC and automation enabled. So it's helped eliminate a lot of manually constructed repetitive tables and views, and improvement in data reliability. There would have been hundreds of printed photos that would have been attached to a printed hard copy report with drawings, with reports, with condition and severity tables. So we've eliminated a lot of that, I guess, manual work there. The collaborative prototyping and review of the deliverables, this helped us speed up and, I guess, pivot throughout the project, which was helped out the heritage architect, and also helped with bring the client and help them get involved. And then also we're able to minimize site visit costs and the elimination of health and safety and working at height. There was no need for a cherry picker or scaffolding, which would have traditionally been how the heritage architect would have assessed the tiles. So out of all that, what are the next steps? So I guess for us, the more internal BIM uses for ourselves is integrating more into facilities management. Traditionally, we've operated in the, I guess, design and construction space. This will allow us to incorporate more into the operational facility use. So we can now use this into our plans. The IFC view of definition, typically, I suppose our software stack is quite proprietary and, I guess, traditional. This is allowing us to better collaborate and use more open formats. And ultimately, the asset handback. This is really going to help us hand back this information into the asset information requirements for clients, and help ultimately with the how assets can work in a facility management project. Ngā mihi nui. Many thanks.
Thank you. Do you want to answer that question, Matt? Or should I have a go? Next time, what would be the handover requirements for the client? So I'll have a go at it. So what you saw earlier in the deck was quite a mature execution or digital engineering framework on the client side. I'd imagine that those documents, those specifications probably wouldn't change much, but it would be more about the supply chain uplift to try and match them. So the actual requirements wouldn't change as such, but in New Zealand it's a little bit looser in terms of contracts and deliverables, hence the experimental emphasis in the project. When we are returning our tender documentation to the client to be hopefully awarded the job, we'll nominate which of the BIM initiatives they've identified and asset information and neutral handover is just sort of coming onto that radar as well. So that would be the approach. We would try and integrate a lot more with the digital engineering team on KiwiRail's side and work with them more as an interpersonal relationship and collaborative process as well. I can actually hear the room, I think, now.
Maybe you have. Yeah, I wasn't sure what the answer was, but
yeah.
I
can hear the room now.
We can hear.
Oh, you can hear me?
It's work.
Yeah.
Okay, so I'll just pick up the mic. Yes, I think this is nice start, really, and intriguing what you've been doing. How do you envisage the continuation when taking care of this and working with all the data that you have collected?
So there's a few processes that KiwiRail are putting in place. The industry approach would be Kobe data sheets, etc. is like probably more code-based exchanges from models, but what KiwiRail are doing, putting their own asset definition viewer and reception process together, which is based on SQL. So it would be being really careful about what we're outputting from our models using information delivery schedules and the like, and agreeing that in the BIM procurement docs. Going forward, we just want to see that there's an aspiration from the client to just see a maturity increase in each and every project that we're engaged with. And that also applies to our competitors as well. So we have in the industry a bit of a New Zealand Inc. kind of agreement, which is outside of our normal contracts, and also an engagement with the New Zealand Digital Twin group that meets every year or so. So there's a strong aspiration on the part of the industry to keep it all moving.
Thank you.
Any further questions from the jury? Nothing more? Okay, perfect. We'll close the session there. Thank you very much, Matt and Matt. Apologies for the technical difficulties. It's a great presentation.
No
problem.
Thanks very
Thanks
much.
very much.
I'm glad it worked. Yeah.
Thanks very much.
Thanks, everybody.
Thanks, everyone. Bye. Ka kite.
Thank you all for joining. We hope to see you.